I grew up in New York State, and my father was a pilot at the old Rhinebeck Aerodrome, so I kind of grew up around rotary engines and World War I airplanes and stuff, and so I've had an interest in it from my earliest days. And some of the earliest memories I have are of a Nieuport 28 with this kind of engine on it, running up, and the sound that it made, and castor oil smoke and the smell of castor oil, burned castor oil, and that kind of thing.
Yeah, the associate director at the Air and Space Museum at Dulles billed you as the world's youngest World War I pilot. Is that true?
Probably not anymore. At one time, I was flying a Fokker triplane when I was 18 years old, so at one point I was, if not the youngest, pretty darn close.
Would you tell us the pedigree on this monosoupe engine?
Yeah, it's a 160 horsepower Gnome monosoupape, which means single valve, because it only has one valve in the cylinder heads, you can see. It's the intake valve and the exhaust valve, and it's a rotary engine. The ignition leads are disconnected, so it shouldn't start yet, but it's a true rotary engine, not like a Wankel rotary engine like you hear about in the cars, and I guess in the 70s I think they had those. But it's very interesting because they spun them like that because they couldn't adequately cool them. This engine has almost 1,000 cubic inches. It's basically as big as a Pratt & Whitney 985, which is 450 horsepower. This is 160 horsepower, but it's only rated at 1,350 RPM. And the problem was they couldn't cast. The casting technology wasn't good enough to cast cylinders with enough cooling fins on it. If you look at a Pratt & Whitney cylinder, it's about the same cubic inch displacement, but it looks much bigger because they've got great big cooling fins on it, and they couldn't cast them that big, and they ended up, these are all machined. Almost every piece of this engine is machined from a solid block of steel. These cylinders started out as a 70-pound block of steel, and they machined everything away till they had what's left here, and it only weighs about 6 or 7 pounds now. But they couldn't get enough cooling fins on it to cool it, and somebody came up with a bright idea, well, we'll spin it around and make it have its own cooling air, and so that's why they had the rotary engine. But of course it causes a lot of other troubles, ignition and fuel supply and that kind of thing. The crankshaft is bolted to the airframe and is stationary, so the engine spins around it, and the crankshaft is hollow, and the fuel and air comes up through the hollow crankshaft, and then there's also air that goes in through this valve. And if you're kind of an engine guy, the technology of it is interesting. It fires at 20 before center, 20 before top dead center, right about there it fires. And then of course it has the power stroke as it goes down the other side, but the power stroke, because they have to get the fuel-air mixture from inside the crankcase into the cylinders, it has ports in the bottom of each cylinder, like a 2-cycle engine, but it's not. It's a 4-cycle, 4-stroke engine. But so they can't have the power stroke go all the way to the bottom because it would the combustion gases would blow up into the crankcase. So the valve actually opens at I think 110 past top center, way over here. The exhaust valve, at that point it's an exhaust valve and it opens, and so you're still having combustion and everything going on there, and so that's one of the reasons it's so loud, and you can't really see the flames come out, but it's basically burning mixture coming out of there. And then it stays open here. The crankcase it basically has enough pressure in it so that there's no give or take as it goes past bottom dead center and the ports are uncovered. And then of course this is a normal exhaust stroke. The valve stays open then from 110 degrees past top center all the way up through here to the top. That's an exhaust stroke, and then it stays open and becomes an intake valve. So it actually stays open through part of the intake, and again they close it somewhere it's past midway down here, 100 degrees or something like that. They close it early so that it'll create a little bit of suction, so when these ports are uncovered, it draws the air in. So the valve is open for something like 370 degrees of rotation. It's partly an exhaust valve, partly an intake valve, and it's pretty interesting.
Does it go through all of those steps in one rotation?
No, two rotations. Two rotations. It's like any 4-stroke engine. It takes 2 revolutions to complete all 4 strokes.
Okay, 2 revolutions.
Yep. You still have intake, power, exhaust, and what are the 4 strokes?
I don't know. Carburation and ignition.
Yeah, there's no carburetor on it. There's a little unit on the side here. It's a Tampere valve. That's the brand name like Kleenex or Xerox. But basically it's a little needle valve, basically a mixture control, and you have a lever in the cockpit that we've got in the back there. And so you can't meter the air going into it. All you can do is meter the fuel going in. And so basically you meter the fuel for peak RPM, and then you adjust the speed of the engine with the ignition. It's got 2 magnetos on it. One of them is normal. The left magneto is normal. That sounds like a gnome back there. And the left magneto is normal. The right magneto is hooked to a selector unit that has a brass disc in it that has micarta inserts in it, or insulating, some kind of insulating inserts on it, and it has a series of brushes on it. And you have a switch on the back that you can see later that has, it's 43210. 4 is normal full power, and it fires 1, 3, 5, 7, 9, 2, 4, 6, 8 like a normal engine would, 2 revolutions. 0 is off, and when you go from 4 to 3, it skips every other one. So it fires 1, skips 3, fires 5, skips 7, fires 9. So you're half power then, and it takes 4 revolutions to fire all the cylinders. If you go to 2, it fires 1, skips 3, 5, 7, fires 9, skips 2, 4, 6. So it's people, there's a common misconception that you're running on 1, 3, 5, 7, or 9 cylinders, but in fact, you're always running on all the cylinders, just in a different order. And at full power, of course, it's 2 revolutions for all the cylinders. At half power, it's 4. And then it goes to quarter power, it's 8. And at 8, you can go to 1/8 power, and it takes 16 revolutions to fire all the cylinders. And it sounds like it's running on one cylinder. It goes bang, 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 but it's a different cylinder every time. So you eventually, I don't know if we'll get to try that out today that much, or if it'll work, but that's how you.
When you start it, what are going to be your settings?
Well, first thing we're going to do, you get an open cylinder in the bottom, a valve that's open in the bottom. You turn the fuel valve on, open the mixture control, and fuel should run out here. Sometimes, because we don't have much of a pressure head, because we've only got a few gallons of fuel, sometimes you have to blow in the vent on the cap to get it to run out. But, well, now it looks like something's running out now, but probably oil. So you get till fuel runs out there, so you know I've got fuel in the crankcase. You spin it over 2 revolutions, turn both magneto switches on, and then pull it through and hope it starts. And then if you want to adjust the speed, you have to shut off the left mag, because it's normal and running full speed all the time, and adjust the speed with the right mag. So it's kind of like rubbing your head and patting your stomach. And
okay, you do what you have to do to start it, and I'll ask you some questions later about your control panel back there.
Yeah, we're going to hook up the ignition leads here, and then I think it'll be ready to try.
Control?
Yeah, can you see it all from over there? You need to come back.
The throttle.
It's not a throttle.
Okay.
This is a Tampere lever. In fact, it says right on it, Tampere. It's a brand name, T-A-M-P-I-E-R.
Yeah.
Rene Tampere is the company that made those valves and made these levers and stuff. Yeah. And it's a mixture control. It works this little needle valve up here, and all that is a needle valve to adjust the mixture on the engine.
Exercise that needle valve for me. I see it. Okay.
And there's a little filter in here, and I'm thinking about putting a little drain plug on there so you could drain it more easily. I think they probably drain them in service to use it as like a gascolator also. But so that's all that's for. And an interesting thing is, if you look at this, it's labeled 0 to 10, and 10 is in front, but 0 is in the back. But it's reversed. On the French airplanes, you pulled back for open and push forward for close, the opposite of what you would think in an American or a British airplane.
That would be the unmaking of me.
Right, me too. That's why I've got it flipped around so it's the other way. This switch controls the left mag, on or off, and this button, it's not hooked up right now, but this is kind of a system simulator I've got here. So this represents, this normally would be the blip button on the stick that you can use. So yeah, either the button on the stick or the mag switch will turn off the left magneto. Then the right magneto is the one that's on the selector unit that has it's 43210. It's on 0 right now, yeah, which is off and normal. And as I say, on 4 is full power. It's runs like a normal engine should run. And then the 3 position is where you go to half speed, and then it's taken 4 revolutions to fire all the plugs. The 2 position, it takes 8 revolutions. It's quarter speed. The 1 position, it's 8th power, 8th power, quarter power, half power, and full power. So that's what this switch is for. But you have to shut off the left mag, obviously, or it's running at full power anyway. So you have to shut off the left mag, use this selector switch, keep the mixture correct, and shoot your guns at the enemy. So you can say you kind of needed 3 hands in the cockpit. And then, of course, the tachometer, it's not hooked up yet, but I've got it mounted in the same distance it'll be in the airplane. So if I can get a cable for it, then it'll be the same cable to use. This is the oil pulsator glass here. We haven't tried that, but it's the oil pressure gauge. It's half full of oil or part full of oil, and when the engine's running, it's a piston type pump, and so as the piston type pump pumps the oil, this level in here should go up and down as the pump goes up and down. And they actually had a chart that you could look at. If your tachometer failed, you could count the number of pulses in a minute, and you could figure out what your RPM of your engine was in case your tachometer failed.
Well, you're operating all that other stuff.
Right, yeah, well, you weren't busy with other stuff. Yeah, we've got the shut-off valve on it now. But maybe we'll run it one more time and see if the pulsator works. But that's the panel, not much. That's all that came in a French airplane. They usually added altimeters and clocks and stuff, but
And you've got like a temporary homemade gas tank up there.
right, yep.
And one half of it is oil?
Well, probably a third of it is oil. It burns about 11 gallons an hour of gas and about 1.5 gallons or 2 gallons of oil.
Castor oil.
Castor oil, yep.